Exposed wire for less than 600 volts is permitted under specific conditions outlined in the National Electrical Code. One approved method is the use of listed cable trays. Cable trays are designed for use in industrial and commercial facilities, providing a raceway for multiple conductors. These trays offer support and organization for wiring systems, ensuring that conductors are properly managed and protected. Conduit bodies can also be used to protect wire splices and terminations in accessible locations. These enclosures provide a secure and code-compliant method for making connections and protecting them from physical damage. Junction boxes serve a similar purpose, offering access for electrical connections and providing protection for wire terminations. They are essential components in any electrical system, ensuring safe and reliable connections. In motor branch circuits, exposed wire can be run to disconnect switches and motor starters. This allows for direct connections to these components, simplifying the wiring process and reducing the need for additional raceways. For motor feeders, electrical metallic tubing, or rigid conduit, or other approved raceways can be used to protect exposed feeders supplying motors. These raceways provide a physical barrier, protecting the conductors from damage and ensuring the integrity of the electrical system. Now let's address the legality of specific installations. Using Unistrut as a raceway is generally not recognized by the NEC. Therefore, its use as a raceway is typically not considered legal. The NEC mandates that raceways meet specific standards for safety and performance, and Unistrut does not typically meet these requirements unless specifically listed and labeled for use as a raceway. Similarly, a perforated angle as a raceway may not be recognized by the NEC unless it is a specifically listed and labeled product. A thorough investigation into the specific product used is necessary to determine its legality. It must meet the NEC requirements for mechanical strength, fire resistance, and conductor support. EMT is a permitted raceway for motor feeder circuits. Its use in this application is generally considered legal, provided it is installed in accordance with the NEC guidelines, including proper support, fittings, and grounding. The NEC allows for exposed wire to be run into motor disconnects and motors under certain conditions, typically within the enclosures of these devices. However, the use of exposed wire throughout an industrial facility, as described, would generally not be considered acceptable. The NEC emphasizes the need for protection against physical damage and electrical hazards. It is recommended to have a qualified electrician review any electrical installation and provide proper recommendations. The electrician should ensure that all raceways and wiring methods used are compliant with the NEC and industry standards. This includes verifying the listing and labeling of raceways and ensuring that conductors are properly protected and supported. In summary, while the NEC permits exposed wiring under specific circumstances, it is crucial to adhere to the code's requirements for raceways, conductor protection, and overall safety. Using approved raceways and wiring methods is essential for maintaining a safe and compliant electrical system. Always consult with a qualified electrician to ensure that your installations meet the NEC standards. This ensures a safe and reliable electrical system that minimizes the risk of electrical hazards. Firstly, raceways must be suitable for the environment. For example, in wet locations, use waterproof or rain-tight fittings and enclosures. Secondly, conductors must be properly sized for the intended load to prevent overheating and potential fire hazards. Thirdly, all electrical connections must be made inside approved enclosures to protect them from physical damage and environmental factors. Fourthly, the grounding system must be properly installed and maintained to provide a safe path for fault currents. Fifthly, use appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect the wiring and equipment from overloads and short circuits. Sixthly, electrical work should only be performed by qualified and licensed electricians to ensure compliance with the NEC and local codes. Seventhly, regular inspections and maintenance of the electrical system can help identify and address potential problems before they become serious hazards. Eighthly, follow manufacturer's instructions for the installation and use of electrical equipment to ensure proper operation and safety. 9. They ensure that all electrical equipment is properly labeled with voltage, amperage, and other relevant information. 10. Keep electrical panels and equipment accessible and free from obstructions to allow for maintenance and emergency access. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Adherence to the NEC is essential for ensuring the safety of people and property. Chapter 3 of the NEC covers wiring methods and materials, providing detailed requirements for conductors, cables, raceways, and other components. Chapter 4 addresses equipment for general use, including requirements for receptacles, switches, and lighting fixtures. Chapter 5 covers special occupancies, such as hazardous locations, healthcare facilities, and swimming pools, where additional safety precautions are necessary. Chapter 6 deals with special equipment, such as electric signs, elevators, and electric vehicles. Chapter 7 covers special conditions, such as emergency systems, standby power systems, and fire alarm systems. Chapter 8 provides requirements for communication systems, such as telephone, cable television, and network cabling. Chapter 9 contains tables and examples to aid in the application of the NEC requirements. Annexa provides information on notes that are not part of the code but offer additional guidance and clarification. The NEC is enforced by local and state electrical inspectors who review electrical plans and inspect installations to ensure compliance with the code. Failure to comply with the NEC can result in fines, penalties, and even legal action. Proper grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault currents, allowing overcurrent protection devices to quickly disconnect the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, minimizing the risk of electric shock. Grounding electrodes, such as ground rods, ground plates, and metal underground water pipes, are used to connect the electrical system to the earth. Bonding jumpers are used to connect metal enclosures, raceways, and equipment together. The size of grounding and bonding conductors is determined by the size of the circuit conductors as specified in the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. Circuit breakers are resettable devices that trip open when an overcurrent occurs. Fuses are one-time devices that must be replaced after they blow. The ampacity of an overcurrent protection device must be matched to the ampacity of the conductors it protects. Arc fault circuit interrupters, or SIs, are special types of circuit breakers that detect arc faults, which are a common cause of electrical fires. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by detecting ground faults. GFCI protection is required in the areas where there is a high risk of contact with water, such as bathrooms, kitchens, and outdoor locations. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes or power line disturbances. SPD divert surge currents to ground, preventing them from damaging sensitive electronic components. Proper wire sizing is essential for ensuring the safe and efficient operation of electrical circuits. The size of the wire must be adequate to carry the intended load without overheating. The NEC provides tables that specify the ampacity of different wire sizes based on the type of insulation and the ambient temperature. Voltage drop is another important factor to consider when sizing wires. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Conductors must be properly insulated to prevent electrical shock and short circuits. Different types of insulation are available for different applications, such as THHN, THWN, and XHHW. The type of insulation must be suitable for the operating temperature and environmental conditions. Conductors must be protected from physical damage by installing them in raceways or using armored cables. Raceways include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. Armored cables include AC cable and NEC cable. Electrical boxes are used to enclose and protect electrical connections and devices. Metal boxes must be grounded to provide a safe path for fault current. Non-metallic boxes are used in non-metallic wiring systems. Boxes must be sized appropriately to accommodate the number of conductors and devices they contain. Receptacles, or outlets, are used to provide a convenient means of connecting electrical equipment to the power supply. Receptacles must be properly grounded and installed in accordance with the NEC requirements. Tamper-resistant receptacles are required in dwelling units to protect children from electrical shock. Switches are used to control the flow of electricity to lighting fixtures and other equipment. Switches must be rated for the voltage and amperage of the circuit they control. Dimmer switches are used to adjust the brightness of lighting fixtures. Lighting fixtures must be installed in accordance with the NEC requirements. The type of fixture must be suitable for the location and the intended use. Recessed lighting fixtures must be rated for insulation contact, or IC, if they are installed in insulated ceilings. Smoke detectors are required in dwelling units to provide early warning of a fire. Smoke detectors must be installed in each sleeping room and on each level of the dwelling unit. Carbon monoxide detectors are required in dwelling units that have fuel burning appliances or an attached garage. Carbon monoxide detectors must be installed on each level of the dwelling unit. Electrical panels, or load centers, are used to distribute electricity to the various circuits in a building. Electrical panels must be properly grounded and labeled. The circuits must be clearly identified with the type and size of the load they serve. Electrical safety is everyone's responsibility. By following the NEC requirements and practicing safe electrical work habits, you can help prevent electrical accidents and ensure the safety of your home or workplace. If you are not qualified to perform electrical work, always hire a licensed electrician.